Hello and welcome to Allied Educare. Allied Educare is the fastest growing online coaching center. Allied Educare representing much more interesting video. I am trying to upload interesting video on a new topic. So previously I have uploaded a topic that deals with HCV RNA PCR. So today I am going to demonstrate how to extract HCV RNA or RNA extraction, how to do RNA extraction. I have collected five sample from five patients that are diagnosed with HCV virus. We know that HCV virus is a RNA virus. So to determine the viral load in the sample, we have to calculate, or we have to identify the viral load. So before going to calculation of the viral load, first our job is to extract the RNA from the sample. So as you see from our upcoming video, that I have collected 5 sample from 5 person that are HCV positive. So stay tuned to us. As you can see, there are 5 reagents that is used for the RNA extraction. According to the kit, we are using GCC Biotech kit. Here there are 5 reagents. First reagent is called TRIzin reagent. TRIzin reagent is the lysing agent. It can lyse the virus, or it can destroy the virus so that RNA can comes out. Second reagent is isopropanol. Isopropanol is a one type of alcohol. It is used for the precipitation of the RNA. In case of in molecular biology, the role of ethanol is very crucial. It just precipitate the DNA or RNA. Actually, DNA or RNA is the water soluble. So isopropanol or any type of ethanol, it may be ethanol, it may be methanol, make the DNA or RNA insoluble so that it can precipitate. Third reagent is chloroform. The chloroform is the one of the crucial reagent among the 5 reagent. It is used for the phase separation. As we later we can see that once the RNA is separated or precipitated from the solution, we can separate it by using chloroform. There is a procedure called phase separation. The chloroform is used for the phase separation. Fourth reagent is membrane wash buffer. Membrane wash buffer used for the washing purpose. It contains ethanol. And last one is, it is a nucleus free water. It is used as a elution buffer. We have to elute as the RNA is extracted. We have to elute from the column. So nucleus free water is used for elution purpose. So the reagent contains total 5 reagent. By using the 5 reagent, we can extract the RNA from any sample. So we have collected 5 samples. We have collected 5 samples. All samples are tested positive for HCV antibody serology. All are HCV positive. So here, from this test, we can demonstrate or we can calculate the viral load. For the treatment purpose or for the medicine dose purpose, we have to calculate or we have to determine the viral load. Until or unless we determine the viral load, the doctor cannot decide it how much dose of medicine the patient should be given. So here our job is to calculate the viral load. Let's get started. First, I have taken 5 tube for 5 sample, and I have given a specific number. Each sample contains a specific number. You can see from here, every sample contains a specific number. So first of all, what we have to do, we have to add 800 microliter TRIzin reagent. So let me add 800 microliter TRIzin reagent. to add 800 microliter TRIzin reagent. I have added TRIzin reagent into the pipe tubes. Next, we need to add 200 microliter sample. So from each tube I have to add 200 microliter sample. After adding TRIzin reagent 800 microliter, we have to add 200 microliter sample from the each tube and to its corresponding tube. Before adding the sample, we have to make sure we need to add exact volume, exact 200 microliter volume. If you take less or more volume, it will affect the viral load. So before adding the volume, we have to make sure that exact 200 volume is aspirated. Now sample addition is completed. Now we need to incubate the tube. Close the lids of the tube, microcentrifuge tube. Then we have to incubate the tube at room temperature for 5 minutes. Incubation for 5 minutes in room temperature is over. Let's move to the next step. After incubation, after adding TRIzin reagent, we have to add 200 microliter chloroform. Here is the reagent, chloroform. We have to add 200 microliter chloroform in each tube. It is an anesthetic agent, so you have to be very careful at the time of addition of chloroform. So add 200 microliter chloroform in each tube. Chloroform addition is done, then close the lid very tightly. Now invert the tube 5 to 10 times. Invert the tube 5 to 10 times. After mixing the tube, we need to centrifuge at 12,000 RPM. So mixing is done. Now this tube are to be centrifuged at 12,000 RPM for 5 minutes. Centrifugation is over. After centrifugation, this tube look like that. Here we can see 3 phases are separated. First one is called aqueous phase. Here all the RNA are collected. If there is a virus in the sample, then virus get lysed. After the lysis, in this aqueous phase, all RNA are collected. This middle portion is called interphase. Here all DNA are collected, and this pink color phase is called aqueous phase. This pink portion is called aqueous phase. Here all the protein or RNAs or any other protein can be collected here. So we have to deal with only this clear aqueous phase. Here all the RNAs are collected, and we have to work with this supernatant, or we have to work with this aqueous phase. In the aqueous phase, RNA are present. So after that, and one thing I forget to mention, that chloroform enhance the phase separation. You can see the phase separation. First one is aqueous phase, second one is interphase, and third one and last one is, and bottom one is organic phase. So this phase separation is enhanced by chloroform. Protein, all protein stays at the bottom. All protein that is not necessary that deposited or get deposited in this phase, all protein stay at the bottom. RNA is extracted to the top aqueous phase in this phase, and DNA evolves as interface. This is the interface. Here all DNA may be settled. So now we have to collect this aqueous phase only. We have to collect only this aqueous phase. Now carefully collect the aqueous phase. Great care should be taken during the collection of aqueous phase so that no other portion gets aspirated, and put the aqueous phase in the separate tube. So here aqueous phase is being collected. So we have to collect only aqueous phase, not the interface or not the organic phase. So all aqueous phase are collected. This is the aqueous phase is collected in the corresponding tube. Now we have to add alcohol. We have to add alcohol, that is isopropanol, 200 microliter. What is the function of the alcohol? Alcohol helps precipitating the RNA. Actually what happened, DNA is, or RNA is soluble in water, as DNA is polar molecule and water is also polar molecule. So DNA can miscible with water, and water can solubilize the DNA. So if DNA is soluble in water, then we have to precipitate out the RNA or DNA. In case of RNA extraction and DNA extraction, in both cases we use alcohol for the precipitating the nucleic acid. So here we use isopropanol to precipitate out the RNA. What alcohol makes? Well, what alcohol makes the RNA precipitate in the matrix. So now we need to add 200 microliter isopropanol in each tube. In each tube there are aqueous phase. So DNA helps in precipitating the RNA. If precipitation is not done, then we cannot extract out the RNA. So I have added isopropanol, then vortex. We need to vortex the tube so that the alcohol can mixes with the aqueous part very well. Now vortex is done. After vortexing, we have to take RNA binding column. This is the RNA binding column. There are two parts. This is called collection tube and this is called column. Here you can see there is a one type of silica column where RNA gets trapped. So this is the RNA binding column. Now we need to load 700 microliter supernatant to the RNA column. We need to load 700 microliter to the RNA binding column from each tube. You must be very careful during the addition of solution in binding tube. Maximum error may occur in this step. You cannot put the total volume in the binding column as the volume is not enough for the binding column. Add 700 microliter solution to the binding column. Then centrifuge the binding column at 12,000 rpm for 30 seconds at room temperature. So this is the binding column. Here we have loaded the solution from here. Then we need to centrifuge at 12,000 rpm for 30 seconds. Centrifugation column is done. As you can see that all of the solution gets filtered out and collected in the collection tube. If there is any RNA particle, it may get trapped. It may get trapped in the column position. Now we have to find out whether the RNA get trapped or not. So now we have to discard the flow through. This is called flow through. This is the column, this is the column, this is the collection tube. All liquid gets filtered out and collected in the collection tube, and if there are any RNA particle, it may get trapped in the column position, in the column. So we have to just discard the flow through and put it back. Discard the flow through and put it back. Now we have to add the leftover solution to the binding column. Leftover. Just put it in the column. The leftover portion is transferred to the column. You can see that leftover portion is transferred, and now the column is centrifuged for the second time at 12,000 rpm for 30 seconds at room temperature. Centrifugation for the second time is done. As seen earlier, the flow through is collected in the collection tube, and if there RNA, it may get trapped in the binding column. So just discard the flow through and put the collection tube back and attach it to the column. Discard the flow through and put it back. Now next step is washing. We use membrane wash buffer to wash the column. It is a membrane wash buffer. It is alcohol based membrane wash buffer. Ethanol is added to the membrane wash buffer, and now we have to add 600 microliter membrane wash buffer to each binding column, and this membrane wash buffer helps purification of the RNA, or it removes the unnecessary protein, unnecessary things that may be there, that may be in the column. So it removes the unnecessary protein or unnecessary things, but it cannot remove the RNA. Once RNA get attached in the membrane or in the column, then until and unless we use elution buffer, it cannot be separated. So add 600 microliter membrane wash buffer, and this washing step will be repeated for 2 times. So open the lid of the binding column and then add membrane wash buffer 600 microliter in each tube. In molecular biology, contamination is the great concern, so you have to be very careful during addition of each reagent. You have to make sure that tip of the if I use same micro tips, then we have to make sure that the micro tips cannot touch the binding column. So membrane wash buffer is added to the binding column, and it is now subjected to centrifugation for 12,000 for 30 minutes 30 seconds at 12,000 rpm. After addition of wash buffer, we have done centrifugation at 12,000 rpm, and centrifugation is done for the first time. And here you can see that all wash buffer gets filtered out and collected in the collection tube. Now discard the wash buffer and put it back. Do not discard the collection tube. You have to attach the collection tube with the binding column. Discard the all wash buffer and repeat the step for the second time. Now, as we have seen that first time, now add wash buffer for the second time and centrifuge it at 12,000 rpm for 1 minute. The time of centrifugation is optional. You can centrifuge it for 30 seconds or you can centrifuge it for 1 minute. Addition of membrane wash vapor is done, then it is subjected to centrifugation for the second time. In washing step, we have done centrifugation for the second time, and it is the last step of washing. Now just discard the flow through from the collection tube. Discard the flow through. I am discarding the flow through from the collection tube and prepare the tube for the dry spin. Next step is dry spin. We need to centrifuge this column with collection tube. No need to add any reagent, just it is subjected to dry spin. The speed of centrifugation is 12,000 rpm and time is 30 seconds or 1 minute as per availability programmed in centrifuge. Then just centrifuge the purpose of dry spin is, you can see there are few droplets left over here. Few droplets are left, so we need to dry the column as far as possible by doing centrifuge at 12,000 rpm for 1 or 2 minutes. You can see there are few droplets left over here, and you have to dry it as far as possible by doing centrifuge without adding any type of reagent. So let's do dry spin. Dry spin is going on at 12,000 rpm for 1 minute, and we are using cooling centrifuge. The temperature is set at 23 degrees centigrade. So here we can see that dry spin is going on, and this is the cooling centrifuge from Beckman Coulter. Model is Allegra 64R centrifuge. It is very good centrifuge, and it is very suitable for any kind of molecular diagnosis or extraction procedure. Dry spin have been done. Then it is time to remove the collection tube and put the column into another tube. I have marked the tube already, so now collect the column. All column are collected and discard the collection tube. And the last step is addition of nucleus-free water. This is the one type of elution buffer. As previously I have told that if there are any virus, then RNA gets extracted from the virus, and if there are any RNA particle, it gets absorbed or attached in the column. So we have to extract out finally. So add 60 microliter of elution buffer into the column. Add 60 microliter nucleus-free water. Open the lid. Then add nucleus-free water to the column. Then it is centrifuged at 12,000 rpm for 1 minute. and the procedure will be completed. The addition of elution buffer is completed. Now close the lid and centrifuge the column at 12,000 rpm for 1 minute. Last step, elution procedure is completed. So now we have to discard the column. Here you can see that the eluted buffer is collected in the collection tube, you can see, and it is stored at -70°C. Then we need to find out the viral load of the sample. Just discard the column. Now no need to use the column. So in this way our total RNA extraction process is completed. So this is how you can do HCV RNA extraction in your molecular laboratory. Now this extracted RNA is stored at -70°C, or it may be stored at -20°C. Then we need to calculate the viral load. Once the viral load is calculated, then the doctor is able to decide how much dose the patient needs to be administered. Stay tuned to Allied Educare. Please do share, subscribe and like, and always support us so that we can bring much more interesting video daily. Thank you.